So we're probably familiar with this identity. It's called the Pythagorean identity, where we have sine squared theta plus cosine squared theta equals 1. But let's prove why this is actually true, and then how we can actually manipulate this to prove other identities. Okay, so if we go back to our unit circle here, we can remember that the radius of the unit circle is 1, right? And so any distance from the center, so this would be 0, comma 0, and to out here to the end of the circle is going to be a length of 1. That's basically what that means. And we can actually draw a triangle here. Basically just distance from here to here, the vertical distance and the horizontal distance. And if we recall, on the unit circle, the horizontal distance, or the x-axis, and the y-axis, we actually define them with sine and cosine. So this is usually defined as cosine, and this is usually defined as sine. So all the coordinates on here, for example, if this is root 2 over 2, comma root 2 over 2, this would be the sine coordinate, and this would be the cosine coordinate. And so that basically means that this horizontal distance we can just mark as cosine of x or cosine of theta, whatever variable you want to use. And then we can say this is sine of theta or sine of x. And so we can just use the Pythagorean theorem here to prove that this is the side length of 1. So if we do sine squared x plus cosine squared x, it has to equal 1 because this is the hypotenuse. And so this is the same thing that we have right here. And you can actually prove this by going to your calculator and writing this. And if you put in the same radian or the same degree, it's always going to equal 1. And so if, for example, we used this coordinate here, this is the coordinate pi over 4, or the radian pi over 4. If we were to do sine squared of pi over 4 plus cosine squared of pi over 4, this is going to equal 1. And so you can check that with your calculator. And so we can actually just go back to this, and now we can kind of manipulate this if we want. So for example, we can subtract cosine from both sides or sine of both sides and see what sine squared actually equals. But we can also do something where, let's just say we want to divide everything by cosine squared.